Hello friends, welcome to our Hariharan Express channel. Today I will discuss regarding on that is hardware implementation of shift unit. Today another topic I will discuss. We have already discussed that is a shift unit, how shift micro operation use used through different micro operations. Normally shift operations used for shifting the number of bits from left to right or right to left. That concept we have already discussed, and today I will discuss regarding on hardware implementation of shift unit. Means what are the components are required to develop or to design that is a shift unit, where different bits can be transferred from left to right or right to left. Okay, so number of possible choice of a shift unit would be a bidirectional shift register with a certain parallel load. We have to take a certain parallel load. It will be a bidirectional shift register we use. Normally whenever you will develop, then a combinational circuit we can use, or we can take a combinational circuit shifter, actually combinational circuit shifter, that will be made with a complex different complexers. Okay, different that is a multiplexers, different multiplexers we use to develop or to design that hardware design hardware implementation of shift unit. Okay, and whenever I go through that particularly that hardware implementation of shift unit, then we have to take it number of multiplexers depend on the number of bits, how many bits we have to design, then based on that number of multiplexer we have to take it. Okay, next that is in that case, suppose we will take that 4 bit that is operations, then we take a 4 multiplexers, and if you go through 4 bit that is operations, then 4 bit shifter having that is 4 data inputs. Okay, 4 data inputs we can also consider. Okay, any that is suppose we have to take for example A is one number, and we have to shift that is from left to right or something, left to right or right to left. Then what happens, we have to divide these particular number into 4 parts, that is A3, A2, A1, A0. Okay, so if we go through shift left to right or right to left, based on that the number of bits will be shift from left to right or right to left. Then some space will be vacant either left hand side or right hand side. That kind of things we have already discussed. So that is actually it is shifted from, suppose left to right like this. Suppose here is left, here is right, and then what happens, left to right, then it is a shift from shift from left to right. A3 occupy next position at A2 position like this. Okay, like this, so it will occupy, so automatically it will be discarded. Suppose that is a left shift you will consider, sorry, right shift left to right, discarded. So this is the basic concept we have already discussed, that is different shifting operation. Okay, but whenever you go through this particular, suppose 4 bits data, then it will shift like this. Similarly 8 bits or 16 bits or any number of bits we can take it. If we go through this particular this category of bits, then number that output also defined accordingly. Here we can get H0, suppose output we can get H0, H1, H2, H3. Okay, this is filled out by this output, very simple way. Suppose we go through this any kind of shifting. Okay, this is the basic concept we have to see. Suppose like this, suppose it is the output, we can tell as output bit or output number, then A1 fill up in H0, A2 fill up in H1, A3 fill up in H2, H3 filled by 0, like this. If we go through logical shift or circular shift, not circular, logical shift. Okay, and similarly some arithmetic shift that is left to right or right to left, like this some concept is there. We have already discussed that part. And if we go through this one, in that case we just consider two serial inputs. If that is two serial inputs, one for shift left, another for shift right. Okay, two serial inputs we will consider. That is a serial input defined, that is a IR. Left hand side we can put IR, that is a, I will show you how it is defined, IR, and the right hand side we can use, that is IL. Okay, in this way we can define, or you can use this IR not that is, it is actually right shift, actually small we can write it better, IR here subscript we can write. Okay, so here what happens, IR in the left hand side, IL in the right hand side, like this we can use. I will show you whenever the function table will use. Okay, and another is we will consider, that is one selection input. Yes, we consider S selection input. S is either 0 or 1, because it is moved from left to right or right to left, it is decided by this particular S. Okay, this is the one selection variable you can consider. And another is it is actually defined like left to right or right to left. I will show you how it is defined. And another is some input data, actually suppose n number of inputs or outputs will define, depend on the how many number of inputs will be considered. Just I already told, that is suppose A having 4 bits, suppose A having 4 bits, A number having 4 bits, so 4 bits you define A0 to A0, A1, A2, A3. Similarly 8 bits A0 to A7, like this we have to define. Based on that we can that is a shift, how many number of shift in between that. Okay, that is IR to IL, like this, or first to last. And all kind of these two serial inputs, actually IR and IL, can be controlled by another multiplexer to provide 3 possible types of shifts, because we have already discussed that is 3 category of shift. One is a logical shift. Okay, we have already discussed logical shift, arithmetic shift, and a circular shift. 3 possible shift we have we can design. Okay, so just we will see how 4-bit combinational circuit shifter design different kind of shift operations. We will see. Okay, now we will start that kind of work, that is a design of or hardware implementation of shift unit, or we can tell as a 4-bit combinational circuit shifter. Okay, very simple way I will show you. You can also find out how it is designed. Since suppose 4-bit we will consider, then what happens, 4 multiplexer we can take it. 4 multiplexer, very simple way, 4 multiplexer we can take. Okay, one part is S part, S defined, that is 0 and 1. Here is a multiplexer, very simple way we can define multiplexer in this way. Okay, so like this we define 4 multiplexers. S 0 1. Here 4 multiplexer we will consider, it will activate, that is 2 part 0 or 1. Very simple way, I just make it. You can also draw accordingly. And this multiplication either 0 or 1, 2 serial. First of all we will see that is 4-bit, how define a 4-bit, like A3, A2, A1, A0. Okay, one part. Another is a selection, also we consider also selection. I will show you how selection is a defined very simple way. I will show you this selection. It is content like this. Okay, and selection, it is a select. Okay, that select, it is defined two ways. One is 0 for shift right, or down. We can write down. I will show you how it is down. Okay, another is 1 for shift left, it is off. Okay, one is down, one is off. Now another is, I told that is two serial inputs we can consider. One is this is serial input, that is IR. Okay, another is serial input, here also we can write a serial input IL in this way. Okay, so this is serial input joined to here first. Okay, IR, serial input IR joined to here, and this is serial input joined to 1, and now other part is there. Here you see this is 0, this 1 is first last is joined, serial input IL and a serial input IR. Other part is not joined. Now I will join it. Okay, how? Here A0, if we go through joined, already 0 there, so any another 0 is there, so that will be joined by, you see, very simple way. I will show you. That is A0 here. Okay, first 0 is joined here, next another 0, whenever joined, then what happens, and here is another 1 is there. 1 is defined or connected for here A1. Okay, another is that 0 also available here also, it connect to here A0. Okay, next A2 connect, that is here 1 is there, here connect A2, one is A2, and another is here is 0, that A2 also connect to 0 here. Okay, and last is A3 connect to 1. Why I connected, I will show you, then you can understand. Okay, now you see all data, A0 connected, A1 connected, A2 connected, A3 connected. Okay, and it has 1 output. We can get 1 output. That is output is H0. Here also H0. Sorry, H1. Here is H2. Here is H3. This output we can get it. Okay. So now we see why I will join this particular A0 to NE1 like this. You see, it is followed by particular, if you go through that is a shift right, here is side down. Down means initially when down, first 0 is followed by IR. After that A0, you see, initially IR followed by 0, next 0 start from A0, next 0 connect from A1, next 0 connect to A2, and in that case A3 will be discarded because initially it will insert by this IR. So at last what happens, A3 will be discarded for this. But this is the concept. Again, if we go through off, Then initially what happens? 1 is followed by IL. Next here 1 is followed by A3. Next this one followed by A2. Next one is followed by A1. You see, very simple way whenever you analyze this one. Okay. So in this way, so different inputs collect from A0 to A3 or and inputs also provided by serial input IR or serial input IL. Like this it will be considered, and here S is decide this particular selection. Selection is decided either 0 or 1. If it is 0, you see very simple way. If it is 0, shift right, down. Shift right means down. 0 we see. 0 whenever go through 0, then what happens? Down. Down means it is right shift. You see right shift. What are the data? It will be shift to right. Then initially what happens? Input IR. Initially input IR, that is here. Again another 0. A0. Next 0 is only 0 is here. 0 is here. What happens? A1. Next 0 is A2. Like this 4-bit data can be considered. Okay, very simple. I will show you, then you can understand. First part is, you see, EP0 right shift. What are the data given? First is followed by right shift IR. So here IR, you see, very simple. IR followed by this one. First IR data. Next only 0 activated. Here is 0. 0 is A0. Obviously A0. Next is 0 is A1. Next A1. Next 0 is A2. Here A2. Okay. Automatically 4 data we can get it. This 1, 2, 3, 4. 4 data we can get it. Okay. Whenever go through down. Similarly, whenever go through off. Off means what happens? You see, first what you write? Off means right hand side. Off. Initially here what you write? Very simple way. We can write here 1. Off means 1. Here 0 is over. If it is 1, 1 for left hand side. Left, shift to left, right to left. Then off, we go to off. Here what we write? 1. 1 means you see A1. Here A1. Because A0 not there. Because already A0 followed by something. Okay. Because A0 is discarded at that time for this left. Okay. Just like the previous that is right, A3 is discarded. Similarly, if we go through left, A0 will be discarded. So A1 is here. Like this, for example, A0, A1, A2, A3 is data is there. Suppose in that case, how it is discarded, which one discarded, which one insert. A0, if we go to left, right to left, A0 obviously discarded because left. A3 followed by A1, A2 position, A2 followed by A1 position, A1 is followed by A0 position, A0 automatically discarded. So A0 discarded. Here what happens? A1 coming here. Next here you see A1. Next one is A2. Here A2. Next one is A3. You see. Next one is A3. And this one followed by input serial IL. You see, it is IL. So two important part, whenever you go through left or right, you just check out this two that is bits, how it is filled out. That is a very simple way we can define. This is the way how to, that is shift right and shift left, either go up or go down. Okay. So this is the basic concept. Now we will take some functional table, then you can understand very easily. Okay. Function table we can define. Now we see select is 1. You see select is 1, either 0 or 1. And output we can get how many? 4 output. Okay. It depend also some serial input and serial input IR and serial input IL. That is okay. Now see S. S is 0 or 1 as you like. We can consider. Okay. 0 or 1. And whenever you go through output, output is H0, okay, H1, H2, H3. Okay. In that case, you see how it is defined. Okay. So now see, if we go through 0, 0 means it's a very simple way mentioned, shift right. shift right means 0, you see shift right and move from left to right. If we move from left to right, then serial input occupy first position 0. You see this 0 occupied by serial input IR. So here output you see IR, we can get IR value from starting. Next 0 it followed by A0, H1 here is H1 actually, H1 followed by A0. You see A0 is A0 and H2 is followed by A1. You see H2 followed by A1 and H3 here is you see H3 0 is which one? A2. So A2 this is followed by A2. Okay, very simple way we can analyze accordingly. Don't worry about this. Here one for shift left means right to left. Okay, off means off. We move from off. So in that case what happens? A1 means 1 you see which one? 1 A1 1 is first position. Here H0 receive the A1 value. So obviously it will be 1 value. Second, similarly you see second one means H1 will be 1 will be A2. So we can write A2. H2 1 is A3. It is A3. Okay, and here one is since it move from off, that is shift left, right to left, this one will be IL. So we can put it as IL. Okay, so either shift left or right, how it is defined, we can very easily we can design. So in this case you see 0, very simple, 0 that is a shift right means left to right, that is down, this is down, and if 1 shift left, that is off. If off, then H1 which data it will receive? Very simple, 0 you see only receive 0, your 0 value, because S is identified 0 is IR, next 0 is A0, next 0 is A1, next 0 is A2. If that is off, shift left, then 1, that is a selection variable is 1 is first one is A1, second one is A2, third one is A3, and last one is IL. Okay, so in this way we can design the whole hardware implementation as well as function table. Okay, so it is very easy to design and to define all parts, how number of components are defined through multiplexers and some serial inputs and some certain number of bits. It is here we consider that is 4 bits. Okay, and some selection variable, only one selection variable, it will define 0 and 1. That 0 and 1 defined either shift left or shift right, and the corresponding function table also defined in this way. Okay, it is very easy way we can also define. Okay, thanks to all to watch my videos, and if you have any comments, you can give comments. Please subscribe my channel. Okay, by which we progress my channel, and also identify any mistake in videos also. Okay, so thanks to all.